In this series of videos, we're going to take a look at how to graph some rather bizarre rational functions. Each video will have a different example, however, this beginning part's going to remain the same. So you may want to skip around and watch the series if you want to see some different examples. The reason this intro is going to remain the same is because some of these rules, all of these rules, apply to every rational function we're going to do. Namely, whatever makes the top of our function equal to 0 is going to be our x-intercepts. Whatever makes the bottom of our fraction equal to 0 is going to tell us where our vertical asymptotes are. And then our horizontal asymptotes, if there is one, is going to depend on what the degree or the highest exponent of the top and bottom of our fractions are. So in other words, the first video will take a look at this example where there's a bigger degree in the bottom. Our second video will take a look at what to do when the degree is equal in the top and bottom. And our final video will take a look at what to do when the top degree is the bigger degree. So let's go ahead and look at our examples. The first thing that I'm going to want to identify are the x-intercepts, if there are any of my graph. To find x-intercepts, we want to see what would make the numerator, the top of the fraction, equal to 0. So literally, I'm going to set the top equal to 0. Well, in this case, the equation I'm working with is 6 equals 0. And of course, 6 never equals 0, and so it turns out there are no x-intercepts in this graph. There's only going to be x-intercepts if there's an x in the numerator. Next up, I'm going to find the vertical asymptotes, and to do that, I'm going to move down to the denominator. I'm going to set the denominator equal to 0. Whatever would make the bottom of the fraction equal to 0 would tell you where the vertical asymptotes are. So this is not factorable, but I could solve it algebraically. I'll subtract 1 from both sides, so I get x squared equals -1. And then when I take the square root of both sides, I get the square root of -1. Well, you'll recall that the square root of a negative number is imaginary, and imaginary numbers do not show up on graphs. So once again, there are also going to be no vertical asymptotes in this rational function. Okay. The last part of this is to find out what your horizontal asymptote is going to be, and you'll recall that this depends on the degree of the top and bottom of the fraction. Well, the degree of the bottom is 2. The highest exponent down here is 2. The degree of the numerator, I suppose I should say it's the highest degree of any variables. If there aren't any variables, that's the degree 0. So in this case, we have a bigger degree on the bottom. So according to our chart, if the bigger degree is on the bottom, I call these being bottom heavy, everything is pushed down to the bottom, pushed down to the axis, and so your horizontal asymptote is actually the axis, the line y equals 0. That was just the rule that we used. And so I guess I'll go ahead and draw that in, and that's the only thing I know about this graph. There's a horizontal asymptote at the line y equals 0. However, that's all I know, and in fact, that's all I'm ever going to know without using my calculator. And so the final part of all of these problems is going to be to graph this using our graphing calculator and then create a sketch of what we see. So let's switch over to the calculator and see what this rational function looks like. The final part of graphing one of these rational functions is actually to graph it, and the only way to really do that accurately and quickly is to use a graphing calculator. So I've entered my equation in. Notice I've used parentheses around the denominator. You'll need parentheses in the numerator or denominator when there's more than one term. You can always use parentheses if you're in doubt, though. So let's go ahead and take a look at what this graph looks like, and you're going to see it's not a hyperbola. In fact, none of these are going to be in any family of functions. They're all going to look very bizarre. So in this case, we can see that we sort of have that horizontal asymptote that we had predicted at y equals 0. No vertical asymptotes. There's no breaks in the graph. This kind of mountain or wizard hat just goes all the way across the screen. So you can see over here I made a sketch just like we did previously with hyperbolas. I don't care about graphing points. If you need to be more accurate or if you want to be more accurate, you can certainly take a look at your table and plot some points from there. Hopefully not those points, some more convenient points. But like I said, I don't need them, so just a sketch that looks roughly like we drew would be just fine with me.